seeing where you're at here. Let's do f of 4. All right. Could you do each of those for me, please?
Yes, but actually, I do remember the the part that I was just really confused on the question on the quiz. It
Yeah.
was like obviously I know how to input the number into the equation or the it's not an
Well,
equation,
let's
but
let's test that. I mean, that's really what this first part is like, can you evaluate the function? Because there are three pieces, right? There's piece one, there's piece two, piece three.
I
All
just
right.
don't know like how you can tell which one to put it
Okay.
into every time because there's four and there's three, right? So
Right. So let's talk about that. Let me get this figured out here. All right. So what is the x value here that I'm giving you for part A?
-2.
-2. First thing you ask yourself is -2 less than 2? And that's the first piece. Is that true?
Yes.
It is. So that tells you which piece to use. It can only be true in one of the pieces.
Okay.
So you're going to put that into the first piece.
Okay. Okay, that's pretty easy. So -4. I think -6. Wait, +1, so -5 for the first one.
It is -5. All right. Now for the second one here, you start with the same question. Is 2 less than 2?
No.
No. And then you go to the next interval. Is 2 between 2 and 4? Not including 2.
No.
No. Is 2 greater than 4?
No.
So this is me just picking something that I didn't know if you'd seen in class. This does not exist.
Oh. Okay.
Usually it will exist, but I just picked one that I don't know why instructor chose to not make this domain continuous, but he or she did.
Okay.
Okay, for 3, it's the same set of questions. Is 3 less than 2?
No.
Is 3 between 2 and 4, including 4?
Yes.
So you use the middle one. You're going to use the middle piece here for that.
Okay.
So go ahead and use that middle piece and tell me what you come up with.
Okay. 3. -1.
Okay. All right. So now 4, f of 4, I want you to figure out, I'm just going to go up here, which of these three pieces we're going to use.
F of 4.
Yes, for 4. When
Okay.
x is 4, which piece are you going to use?
Uh, it's not less than 2. Oh, so it has to be the middle one then.
It is. So it's not necessarily that you're like going to use each one. It could be, could not be. We don't really know. So it's 2 times 4 minus 7 is +1.
Okay.
All right. Any questions on that?
No.
All right. And we'll get to yours in a moment here. We're just
Okay.
covering kind of how to do it, and then we'll make sure you know how to do that one. All right. So the next thing for graphing is you're going to graph each piece. And it's always the challenge of like, well, what goes in each piece, which is different than evaluating it. So for the first piece, you will generally be starting at the end point. Okay. Now with square roots, you got to be really, really careful here because you have to be able to take the square root of the number. All right. And I'll help here because this isn't the real one. But is there a number that you can actually take the next square root of? There is. It's 1. Okay, we'll talk about why in a moment. And then you already grabbed the other one. Let's go. Let me see if I can just get this to fit a little nicer. Let's do that. Okay. So I'd like you to give me the output in that first piece, please.
The you said the first piece or the third piece? Sorry.
The first piece. All
Okay.
these numbers are in the first piece. Now, you could sit here and argue with me and you would be right to say, you know, hey, like two isn't less than two. And I'm like, you're right. Because at two, it's an open circle. The rest of these are going to be filled in.
Okay. So you can do that anytime that it's
When you're graphing, not when you're evaluating.
okay.
You have to do it when you're graphing.
All right. Okay. Um. One.
For what?
One
For which?
for
For which?
sorry. One for two, or two
Okay,
comma one,
good. Like that better.
and then one. And then one comma negative two.
Okay,
Unless I.
it's okay to me.
Okay, and then let me move that. And then two. So and then two, negative five.
Okay. I like to graph as you go. Um, so I would recommend doing that on your quiz.
Okay.
Uh, it's your teacher may tell you to wait till the end. I think it's better to do it as you go. Because there's a lot going on when you graph it. So at 2, 1, why is it an open why isn't it an open circle when x equals 2?
Because the less than or equal to sign.
Well, if it were less than or equal to, it would be
Or
a filled in one.
yeah,
Less
less.
than yeah.
Right.
It's a
Okay.
small little nuance thing. There's 2, 1. Wow, that's totally wrong. 2, 1, 1, -2, and -2, -5. So that's down 2, 4, 5 right there. Now, what type of function is this first one? What's the name for this symbol here?
Um. Well, that is a shit. I wrote it down. Where did it go? Um. I mean quadratic, maybe. I don't
Well,
know.
maybe. Okay. Let's see if we can do a little better here. Let me send you a reference sheet for parent functions, and let's see if you can give me a better answer than that. Let me see if this one's any good. Yeah, this one looks okay. Um, the name isn't that important, but we'd like you to be better than just guessing. So could you look at this one and it is on there. They give it a different name, but maybe you can tell me which one it is.
It says radical.
Yeah, radical root functions. This one might be slightly better for you in this class. I like to print out reference sheets. I know we're used to, or at least take a screenshot of it and save it just so you got something handy.
Yeah.
It's not like social media where it'll mess up your feed if you take a picture of, parent functions, you'll be okay. So the reason I
Okay.
bring that up is you have to know the shape of this. You have to know there's a little bit of curvature to it. It's not
Okay.
just straight line segments between there. Okay, so that's the first piece. The second piece, when it's constrained on both sides, you just check the endpoints. Okay, so could you put each of those endpoints into that middle piece, please?
Yes. Okay. So when there's only one point, then you know that you have to put input other points, right?
Other points, and you have to be careful with which ones you choose. That way they actually work.
Okay. Um. So two comma negative three,
Okay,
and then for one.
all right. Now, is it an open or a closed circle at each?
Um, well, 2, -3 is open, and 4, 1 is closed.
Very good. Now it's a line, it's linear, so you only need the two endpoints for that. 2, -3, 4, 1, and you just connect the dots there. Is that clear?
Yeah.
All right, for the last one, it's x greater than 4. So we ought to try a couple of points here, maybe 4, 5, and 6.
Okay.
Give me the outputs there, please.
Wait, I'm trying to remember. PEMDAS, I think, is the
It
phrase.
is. For simplifying, that is true. You
Okay.
want to
Okay.
do what's inside parentheses first,
Yeah.
then square, then negate, then add 3.
-1. So 4, comma 2.
Okay, good.
And then we have 3, 5, comma 3.
Okay.
And then uh wait, I think I did that wrong. Hold up. 1, 6, comma 2.
Okay. Is it an open or closed circle at 4, comma 2?
Open.
All right, I agree. The other ones are closed. All right, so when we graph this, it's 4, 2, 5, 3, 6, 2. The third piece, what's the name for that graph?
The third one, that one is quadratic.
Okay. So it's got a U shape, and we kind of have an idea of like what's going on because it's got kind of this shape right here. So it's either going to go down or it's going to open up. This one goes down, so you know it kind of does that.
How do you know? How do you know that? Sorry.
Well, if you just connect the three, how can you connect through? Well, it's got to have that downward facing,
Okay. Yeah. Yeah.
round. So you keep going. Now, if
All
you're
right.
really unsure, you just keep adding points until you are sure.
Yeah. All right.
Any questions on that?
Nope.
Okay, so before we do anything else in this one, we really could get to your question. So can you send that over?
Yes. Let me do that.
Right. So good news here is you don't actually have to do the graphing, all of it. Oh, you do. I'm sorry, you do have to graph it. I apologize. Okay, so nice thing is you got an easier one than what was given there. Um,
Okay.
which I mean, I don't know if that's good or bad, but that's okay. So yeah, let me get this uploaded to oh no. Right. Just another moment here. where I can grab this. Do you anticipate getting the same question or variation on this?
When we retake it,
Yeah.
yeah, it's gonna be the same question.
Okay. All right. So easier when there's two pieces. And this domain is continuous. We'll talk about why in a moment. It's going to work in one or the other. Which piece does this work in?
Let's see. It should work in the first one, right?
Yes, -5 is less than -2.
Yes. Okay.
Okay, so I'd like you to evaluate that for me, please.
Okay. Um, -13, -5, comma -13, right?
No, don't look at your friend's paper. Your friend has some mistakes on there.
Oh no, I
So,
wasn't. I wasn't looking at it. I thought.
okay. Meaning there's a way to present the answer, and the answer is just -13. That's it. Nothing more, nothing less.
Oh, okay.
Now, is it true that the ordered pair is -5, -13? Yes, but this is not what they're asking for.
Okay.
And you got to be especially careful when you have prior knowledge, we'll say, to not provide something that if an instructor sees a lot of students consistently writing something like this, they should reasonably know that there's an issue.
Okay.
Okay. Now for the second piece, all right, which is x squared minus 3, when you evaluate, you really want to treat it like this, where it parentheses x squared minus 3. The number that's being squared is in parentheses. Okay, so when you find f of -2, that -2 is going in parentheses.
Okay. It's uh, it's still one, right?
I just have this sense that you're looking at the picture. Try to just
No,
work it
I'm
out
actually not.
without, yeah. Okay. Okay. Give me
I
your
don't
answer
have
more.
anything like pulled
Okay.
up.
Yeah. Give me your answer with more certainty. What is the
Okay,
answer?
just the we were talking about the parentheses. I was like, now I'm getting suspicious of myself.
No, no.
No.
-2 squared means multiply -2 times -2.
Okay. So yeah, 4 and then 1.
Yes. So the answer is 1. That's it. Nothing more, nothing less. Right. And I'm not accusing you of anything. I have my suspicions because
Yeah.
I hear a lot of people talking and can sort of know things, but if that's not the case, that's fine. Last one here. Go ahead and try this one, please.
All right. So it would go in the second one.
Agreed.
So 4 times 4, 16. So 13. Just 13, right?
Okay, that is correct. It is 4 squared minus 3. 16 minus 3 is 13. That's it.
All right.
All right, very good. So now we're going to graph this thing. And the best way to graph it is to make a table. Now you need two tables this time because you have two pieces. For the first piece, you're starting at -2. It says choose values less than -2. What's a value less than -2?
-3.
-3 and maybe -4. Okay, so I want you to evaluate the first function there, please.
Okay. Um.
First piece of the function.
So -2, -4.
Okay.
Um, Hold on, sorry. -9, -8, -7. So -3, comma -7. Um, -12. So -4, comma -10.
All right. Is it an open or closed at the first one? Circle.
Open.
Open, and then the others are filled in. Let's do a quick sketch of this graph as you go, is my recommendation. All right,
Wait, I
so
have a
negative
question.
two. Go ahead,
I have a question. Can
of
you?
course.
Okay. So if it says greater than or equal to, you can't use, so like for the second equation or the second function thing, right?
Yeah,
You can't, even though it could be equal to, since it's closed, can you not use -2 as your first number?
you do use -2 on that.
Okay, okay,
And
okay.
it's a closed circle.
All right.
Okay, let's graph this first one. -2, -4, -3, -7, and then I run out of room. Why did I put an arrow this time, which I may or may not have done previously? Any idea on that?
Um, no, I don't know.
So less than -2 means left forever. It doesn't stop at where your table stops. It continues forever, even though it's not on our graph.
Okay. Hmm.
So make sure you include that arrow.
All right.
It means keep going, even if you don't understand yet. I mean, eventually you will get caught up and you'll fully understand all this stuff, but might be
Yeah, it's a little
another bit.
weird. For
Yeah.
me, I don't know.
All right. So if that's clear, let's go on to the second one. Like you said, it's it does start at -2, but now you need to pick numbers greater than or equal to -2. What's a number greater than or equal to -2?
-1.
-1, and then maybe 0. And then the question is, well, how far should we go? And that's where you have to know a little bit more about what this actual function is.
Okay.
And it's a quadratic, which means it either opens up or it opens down. And just because we kind of have an idea here, I'm going to suggest that you go out this far with your table. So could you fill in the y values, and then we'll talk about um, why those work.
Okay. Yeah. -2, 1.
Okay,
-1, -2.
very good.
0, -3. 1, -2. Yeah. Uh, 2, 1.
Okay. So notice some symmetry here in the answers. These are the
Yeah.
same. These are the same. That is the case. There's something special about this point, which you would have maybe uh, would have learned at previous to now. But let's just go ahead and graph these. So -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. So what you have to be really careful of here is that it only goes to the right. to the right. You don't keep going up this way. This is a break point.
Okay. Wait. You said wait. That's a closed circle, or
Yeah, to the right forever. You're going this direction. There's like a path.
that's. How do you know that it's that circle that that's the break point, not the other? Like flipped.
Well, it's based on these symbols here.
Okay.
I feel like that it's still unclear based on the way you asked that. The less than is an open circle. Greater than or equal to is a filled in.
Okay. Oh, okay. Okay. I think I'm getting it a little bit better.
Okay. So this is what the graph looks like. Like you have to be able to replicate this. Even if you don't fully understand it, you have to fully replicate it here. Um,
Okay.
okay. So now we can do the rest of this. So uh any questions though on what we just did to follow up? I mean, happy to try to answer them. Uh,
I mean, it's a little weird, like how that they like go on forever.
okay.
That's a little confusing, but other than that, I understand that.
All right. So let's look at the stuff on the right now, this middle behavior, the x coordinate stuff. And actually we're gonna use this, we're gonna have this kind of be part of it. So, all right. This is actually all written in the wrong order. First thing you should be asked for is the x coordinate of the discontinuity. Um, Discontinuous means when you draw it, you have to lift up your pencil. Do you see how from this open circle to this closed circle, you have to lift up your pencil?
Yeah.
So what is the x coordinate of the discontinuity? What's the x value there?
-2.
It's -2.
That's easy. Hmm.
Yeah. And then what type of discontinuity is it? There's three types. This one's called a jump. It's a jump because there's a literal gap there. This is a gap. You jump over a gap.
Okay. Oh, so that's it.
That's it.
Okay.
Then you can do the middle behavior. So this is where you need to know the discontinuity. So it's as x approaches -2 from the left. Remember we used that notation.
Yeah.
As x approaches -2 from the right. So if you wonder, well, where did -2 come from? It came from the discontinuity, and then there's going to be from the left, from the right. You have to give me the value that it approaches, the y value. So from the left here, what is
Yeah.
the y value there? From the left.
That would be negative. Is that 1, 4? -4.
-4. And then from the right,
Just 1.
+1. Okay. Do you have a printer at home?
Yeah.
You might consider converting this picture to a PDF, black and white, printing it out a few times and trying to work through like this on your own. That will definitely help.
Okay.
So long as it's the same. All right, let's do the rest of it. Analyzing key features of the graph. Should I do this on the right here? I'm going to grab a picture grab the graph one more time. Okay, so the domain actually has nothing to do with the graph. It has to do with the original function. The original function says use the first piece for x less than -2, the second piece for x greater than or equal to -2. There is this breakpoint at -2, but it's over. The overlap is here with the equal to.
Okay.
So even though it's like, oh, well, that's less than, that's greater than, because there's this line, you're okay. It covers everything. So domain is different than like discontinuity and stuff like that. The domain here is all real numbers. There's no restrictions. When you say less than -2 on a number line, that means there's -2, everything to the left of it. But then when you say greater than or equal to -2, you fill in that dot and go everything to the right of it.
Okay.
Now the range is more complicated because there's this break in it. Okay. The range is like min to max. Let me write it so this is incomplete here. You'd have a comma, and then you'd have y less than -4, comma, y greater than or equal to -3. So take a look at the graph here, specifically this piece. Can you tell me, or do you agree with or understand why it's y less than -4?
Less than. Okay. Because that's. Uh, I mean, I like understand that those are like the two like key like points, I guess.
Well,
Um,
-4 is like it's like the peak. This is the
is the what? Sorry.
top or the peak. Like you see how like there's like the biggest y value of this first piece. Everything is less than, underneath, below.
Yeah.
That's what we're trying to say here. That's the first piece.
Okay. Why would it be? I thought it would. Why isn't it not greater than like the x is then?
It has nothing to do with the x. Ranges are just the y values.
Or sorry, why is the? I mean, not the x. Sorry, but why? Yeah, the second y coordinate or the second y
So,
point for the.
so that's
Uh,
the minimum y value. The y value is smallest y value is -3, but it goes up forever.
oh, okay.
But there's this little in between area where it's not defined.
Okay.
Okay. Um, Now the end behavior, this is more difficult. It's something we have not covered, but as x goes to infinity, this means to the right forever. So you're on the second piece and you're going to the right forever, right? You're following this curve.
Yeah.
Where does it go? What is the y value? What is the what does the y
Infinity.
value go to?
Infinity.
Infinity, yeah. Goes up forever. And then you also need to say as x goes to -infinity, what happens the other direction? So in this case, you're on this other piece. Well, how far down does this go?
Also negative infinity.
Yeah. Okay. All right. So there it is. Now, what you have to do between now and the quiz is you have to figure out how you're going to remember all this stuff.
Okay.
And I don't really know what I would recommend redoing it a couple of times, like redoing it um tonight, once in the morning or at lunchtime, whatever. Something sometime you do it 2 times and you should have it.
Okay.
Um, but that's only because we know this. Like normally I would say let's do another problem and we'll try to guess. Like I was way off in what I was giving earlier. It was way more complicated than this. So um
All right. That's good.
yeah. So I don't know. I mean I'm not really sure what to do now because it will work against you for us to do a different problem. I don't want to complicate, but basically everything from here in the notes you'll want to you get down.
Yeah. Keep studying.
Yeah.
Can do that.
Okay, so we got some time left. How would you
Mhm.
like us to use it today? We do not,
Uh,
we do not, we do not have to like use it if you're like, hey, I don't want to do anything else. But I'm happy to provide more questions or do
um,
something totally unrelated.
I don't know. What are you thinking? Any ideas or no?
I would just throw out some SAT questions just to see how
Okay.
you're doing on some other stuff.
Yeah, we can do that. Sounds fun.
It's somewhat related to what we've been doing. All right. Have you taken the SAT yet?
No, not yet.
The SAT?
Nope.
I thought you guys took that recently at your school.
I think I'm doing it next year. I don't know.
You're in grade 10?
Yeah.
Okay. Yeah, I guess that's that. Yeah, okay.
Okay. Just
All right, so here's a practice question. Practice SAT, ACT question. I'm just gonna throw it up. You can solve it however you want. You can try the answers, you can guess. I mean, that's not the best strategy, but see if you can figure this out, please.
okay. The positive solution. Let's see. Wait, is the SAT timed?
Yes.
Like how long? How much time do you have?
You want to be able to solve a question like this in under a minute,
Okay. Oh,
which
all right.
we're
Minute
which I am
starting.
to which
Minutes.
I already started timing you.
Crap.
You're at 30 seconds.
Crap. Okay. I'll do it in quicker than that.
Fast and wrong is still wrong, so take enough time to get the right answer.
Okay. It's 9.
It is 9, and you did that plenty of time to spare.
Sweet.
Okay. All right. Here is another question. So I do teach like full classes on how to learn the strategies, lots of problems, but I'm not going to dive into any of that today. Just do what you can here, whatever makes sense to you.
All right. Let's see. Ooh, this is a little weird. Uh, mm, I think it's uh I'm gonna go with 1. I don't really know like
This one
oh
says not a solution. Does that
oh
change
oh
how
whoops.
you want to answer it?
Yes, because that is a solution. Sorry. Okay, it's A.
It is A. A is the only one. So not actually means that there are three that work or three that are correct and one that does not work. Wrong.
Okay.
It's a little bit of a mind leap. that, to do this. So, um, let me grab another question here. See if you can answer this one, please.
All right. Mm-mm-mm. Square. Oh, it's C.
It is, why is it C? Why isn't it A?
Well, square root of x equals 8, and the square root of 64 is 8.
Good. Good. Yeah, there's one thing to talk about is that there's only certain numbers that you can take the square root of, and we kind of already addressed that in your tables that we were doing. It's not an infinite list. So if you don't get something on this list, like you cannot take the square root of 8, you can't take the square root of 140. There's actually two answers that aren't even reasonable at this point. And this list goes on, infinitely, but there's like worth knowing some, not all. Um, so here's just a slightly more difficult version of that question. So try to keep in mind what I just mentioned because it's easy to try answers that just don't even make sense.
Okay. So let's see. Square root of x. Oh, x equals 9. Okay. I gotta start reading that first, man. Okay, it's D.
All right, so let's try it. Square root of 79 plus 2 minus 9, does that equal 0? Yes, it does. Good. All right, let's make this our last question for today.
All right.
Here we go. Okay, give that one a try, please.
Now the trickiest one to end the day off. Or is it the
Uh,
trickiest?
None of these are that way. You got to use that thing I just mentioned where you can only take the square root of certain numbers.
Uh, hmm. Oh, this is weird, man. Oh boy, I don't know if I'm gonna get this one.
All right, well, let's just try 8. What is 8 plus 28?
That is 36.
Can you take the square root of 36?
Yes, 6.
How about the square root of 9? Can you take the square root of 9?
Um, yes.
You can. Now, what's interesting about this one is, and I would have put that down here, is if you try 9 plus 28, you can't do. 9 plus 1, you can't do. 26 plus 28, you can't do. 26 plus 20 plus 1, can't do. That's why it's not a great answer space, but sometimes just try the answers and see what you come up with.
Okay.
All right,
Hmm.
good.